Students, in this video we will learn about the drift velocity. Consider about the conductor made of atoms. At room temperature, electrons revolving in the outermost orbit of each atom, getting some extra energy. This energy is called thermal energy or heat energy. Due to getting the heat energy or thermal energy, electron detached from the atom, okay, and free to move inside the conductor. And now let consider about this atom. The electron detached from here moves along this direction and collide with this electron. Now the velocity of this electron moving along this direction is called the thermal velocity. Now the thermal velocity of this electron after the collision will be 0. Okay, now again on getting the external energy or thermal energy, it begin to start move in different direction. Let it moves along this direction and collides with this electron atom. Now after the collision, it will change their path and begin to move along this direction. This another atom is there, so it will collide with this atom and will change their path and will go along this direction. Okay, you can see in this diagram the path of free electron is zigzag. So this electron moves in zigzag path. The number of free electrons are in huge amount in this conductor. That's why all the free electrons will move in zigzag motion. Okay, now and the velocities of these electrons are called the thermal velocity. Let the thermal velocity of first electron is vector u1, thermal velocity of second electron vector u2, and let the thermal velocity of nth electron vector un. Then the average thermal velocity of free electrons will be vector u1 plus vector u2 and up to vector un upon n, where n is the number of electrons in the conductor. So the average of thermal velocities of electrons U average will be equal this. And now in the previous video already we have studied that the average thermal velocity of free electrons equal to 0. Okay, now an external field is applied across the terminals of the conductor. So here battery is connected to the two ends of the conductor, positive terminal and negative terminal of the battery. Positive terminal of the battery is connected to this end and negative terminal is connected to this end. So in this end here positive potential will be developed, and here due to the connection of with the negative terminal, here negative potential will be developed. Okay, now in the influence of electric field, now here the direction of electric field will be positive phase to the negative phase, vector E. Okay, in the influence of the external electric field, free electrons experience some pull or the attraction. Okay, now due to this positive phase, now when in the absence of external electric field, the electron detached from this atom would follow this path, but in the influence of the external electric field, it will experience a pull or attraction along this direction towards the positive face of the conductor, and this force will be vector F, and actually this force is the electrical force. So the electron experiences an electrical force will be E minus E vector E. From where? Because the force on the charged particle is vector F equal QE from this equation. Okay, now this force is experienced by the free electron. That's why in the presence of external electric field, electron will not follow this path. Electron will not follow this path, but electron experiences a force towards the positive phase, and electron will follow this path. Okay, actually electron would reach here, but in the presence of external electric field, electron reaches at this point. Okay, now after colliding, it will go along this direction, and after the collision it will go along this direction. So after applying the external electric field, here the motion of the free electrons are also zigzag, but all the electrons experience some pull or the external electrical force towards the positive face of the conductor. That's why all the electrons are drifted towards the positive face of the conductor. Okay, due to the electrical force. The electrical force acting on the electron is this, let, because the velocity of each electron after the collision is 0, and after some time it begin to go in different direction. So the velocity of electron will also increase slowly. So here the velocity of free electron changes. Okay, due to the change in velocity of free electron, here acceleration is produced. So from the formula, from the second law of motion, F is equal to ma, vector ma. So the acceleration will be vector A equal vector F upon m, where m is the mass of the electron and F is the electrical force, and vector A is the acceleration of the free electron. Okay, now this is second equation, this is first equation. You know the equations of kinematics. The first equation of kinematic is V equal U plus AT, where V is the final velocity of the moving particle, U is the initial velocity of moving particle, and A is the acceleration of moving particle, and tau is the time taken by the moving particle. Okay, here in the case of this conductor, here in the absence of external electric field, the thermal velocity is thermal velocity will be there of the electrons. So the thermal velocity of each electron in the absence of external electric field is taken as the initial velocity, and the velocity of electron after or in the presence of the external electric field is taken as the final velocity of free electrons. So from this kinematic equation, the final velocity or the velocity after applying the external electric field, the velocity of first electron will be vector v1 equal vector u1 plus vector a and tau 1. Here why tau 1 is there? Tau, actually the relaxation time is represented by the tau. So here the relaxation time of first electron is tau 1. Similarly for second electron, here v2, vector v2 will be vector u2 plus vector a into tau 2. Why here a is common for both equations? Because when external field is constant, then the acceleration produced in the free electron is same for each electron. Why? Because the magnitude of the applied external electric field is constant. Okay. Now, if applied external field is increased, then the acceleration will increase or acceleration will change. We are considering here at the constant external applied field. Now, and for the nth electron, vector vn will be vector un plus vector a into tau n. Now, the average velocity after applying the external electric field of all the free electrons, V average will be equal V1 plus V2 plus up to Vn upon n. On putting the value of V1, V2 and V1 from above equations, so it will be V average is equal, the value of V1, vector u1 plus vector a tau 1 plus the value of v2, vector u2 plus vector a tau 2 and plus the value of vector vn, vector un plus vector a into vector into tau n upon n. Okay, or this equation can be written as vector u1 plus vector u2 plus up to vector un upon n plus second part of each vector a into tau 1 plus vector a into tau 2 and plus vector a into tau n upon n. Okay, now or the equation can be written as V average vector u1 plus vector u2 plus up to vector un upon n plus here on taking common vector a from each part of this section, so it will vector a tau 1 plus tau 2 plus up to tau n upon n. Okay, here vector u1 plus vector u2 plus vector un upon n, this is the average velocity in the absence of external electric field, and this is the average thermal velocity of free electrons, and this is equal to 0 from this equation. So here it will be 0 plus, now this is tau 1 plus tau 2 plus up to tau n upon n. This is the average relaxation time. So average relaxation time can be written as tau and vector A, this one. So this is the average velocity, okay, or V average will be equal vector A tau. Okay, this average velocity is the drift velocity. Actually, drift velocity is the average velocity of free electrons in the presence of external electric field. So this velocity is the average velocity of free electrons in the presence of external electric field. So this velocity will be called the drift velocity. So we can here put drift velocity Vd. Drift velocity Vd equal vector A into tau. But the value of vector A, what is the value of vector A? The value of vector A is here vector A equal vector F upon M, but F equal minus E into vector E. That's why A will be equal minus E vector E upon M. So the value of vector A is equal minus E capital vector E upon M. So on putting the value of vector A here minus E vector E upon M into tau, or Vd will be equal minus E vector E upon M into tau. So this is the formula or the expression for the drift velocity of free electrons. Is okay? Okay, thanks.